So first of all, thank you for attending this presentation. My name is Víctor, and this will be a co-joint presentation between Java user groups from Latin America. And we will be basically speaking about some experiences of integrating metrics in Java EE applications. And Jorge is a software developer in Latin America. He has a lot of experience in Java EE. And Jose, he's from Peru. He has this complete view because he has been developing software for Java EE and Spring stacks. So the main idea of this presentation is to do a little bit of discussion about what's the importance of metrics and how could you integrate metrics in your application. So first of all, I want to do a couple of questions to identify some stronger points in the audience and to share some point of views. If you want to stop me to ask a question, just do it. And we will have a couple of minutes in the end to do final questions. So please go ahead. So I want to start the presentation with this question. How many of you have been using Java EE in production in this year? Okay, which version have you been using? 7 version? Java EE 7? Okay, there is one. Java EE 8? 2? And the others, I think you are using Java EE 6, Java EE 5, a mixture of stack, okay? How many of you know about the MicroProfile project? 1, 2, 3. Okay, how many of you have been using Spring to develop microservices? 1, 2, 3, 4, okay. This will be an interesting discussion on how many of you have metrics in your application. 1, 2, 3. Okay, so the main idea of this presentation is to justify why you have to integrate metrics in your application and how could you do it better by using MicroProfile as an alternative. For do it specifically for Java EE, but for those that are doing microservices with Spring, you will notice something that we will be using the same annotations because the MicroProfile API was created by taking Drop Wizard as the basis for the creation of the implementation. So Spring Boot 1, at least the first version of Spring Boot, it also integrated Drop Wizard. So you will find some familiar concepts in this presentation. So, well, as I said, we are basically Java EE developers like you. I'm mostly focused on street development. I have clients from banking, telecom, and other kind of enterprise sector. So I'm basically an enterprise developer. I'm also a recent Java champion and Oracle groundbreaker, but that doesn't matter too much for this presentation. Jorge is also a jog leader in Guatemala. You could follow him on his Twitter. You could do some questions and answers in there. And Jose, he came from Peru to complement our presentation. So, first of all, why metrics? We have to switch places because the presentation is being recorded and streamed live, so they have to come here and go by, so it will be funnier in the end, I think. So what do you think about metrics? Why do you want to integrate metrics in your applications? I have a couple of opinions in here.
Why metrics? With our metrics, we are like blind in production. We don't know how our application is behaving, what's happening in real time. So we need some metrics to make decisions, to make optimizations, and we need to know in real time what's happening in production. That's why we need metrics.
Okay, I think it will be easier. You stay.
Okay. For me, it's a simple phrase. What you cannot measure, you cannot control. In production, you have many problems. You have you need to adapt solution very fast. The metrics is for architects and developers the solution.
Okay, so behind the main idea about why do you need metrics, the basic concept of metrics is that you will have a real-time implementation in which you could acquire information from your running application to see their state, the full stack state, the server's state, and the application state. This presentation is focused mainly on the app server state and the application state. So once I did this kind of question and they said to me, well, I need metrics because the Devops manifesto says that you have to implement monitoring and logging. And that's true. If you go to, for instance, Amazon Web Services implementation of Devops, they highlight this monitoring and logging section because if you want to achieve real Devops implementations, you have to implement metrics and logging. because you have to react fast in order to provide a good service to your clients and to any other developers consuming your APIs. So this is the main motivation to implement metrics in the DevOps way. But what about non-DevOps? In the past, I developed applications specifically for the banking sector in Latin America. And the banking sector in Latin America is pretty particular because 10 years ago, 15 years ago, it was fine, it was okay to stop an application. They just say to the clients, oh, we don't have system and that's it. But nowadays, we have to maintain a 24/7 operation in which you have to be monitoring the state of your application in real time. So you don't have the opportunity to stop. And that's why I do believe that it is important to integrate metrics. It doesn't matter if you have DevOps or you don't have DevOps implemented, because, for me, I think that I have a 50-50 implementation between applications with a DevOps process, between team, developers, operations, but I also act as a consultant, so I do a lot of implementations and research for companies that don't have DevOps at all. These are like regular software shops that don't do DevOps, but I think that metrics are important in this scenario too. So what about monoliths? How do you monitor monoliths? Any of you have some idea on how do you get the state of your application in monoliths? How do you do it at this time? JMX, anyone is using JMX? Okay, there is a user of JMX. Any other implementation? Okay, so let's discuss this. Applications in monoliths have, for metrics, three particular characteristics. The first one is that you will be deploying the application into the application server. So you basically have long-running JVM processes. And it doesn't matter if you want to scale it with a cluster. You will be running a long-running process, in another instant, another long-running process, and you will be scaling by basically copying the entire application server with all the set of applications. And basically, you will try to never reboot the application server. Why? Because it is expensive to reboot an application server. So regular application servers like Payara or Wildfly, depending on how many applications do you have in the monolith, you will take like between 1 minute to 5 minutes to reboot the monolith. So it is expensive to reboot them. If you go to other traditional application servers like WebSphere or WebLogic, you will take more time. So these are the ideal conditions in which you will be scaling your applications. And in this particular scenario, you basically have three options to retrieve metrics from your applications. The first one is that you could actually rely on the telemetric API that is implemented in your application server. For instance, for Glassfish users, there is a REST API called Glassfish Metrics in which you will connect to the application server and retrieve information. The second option, the traditional JVMX implementation, in which you will open a port in the application server. After opening the port, you will connect remotely by using VisualVM or mission control software, to name a few, and you will retrieve and pull the information by using mbins or metrical bins. And the third option will be basically parsing and analyzing the logs. Maybe you could send this log to Logstash or Kibana or some kind of information. But these are the three ways in which you could retrieve information. So how many of you see a problem in these implementations? I see many problems in here. The first one is that you have to open the port, actually. So if you are running in a platform as a service, if you are not on-premise or infrastructure as a service, first of all, you want to secure the communication between your JMX client with your server implementation. So it will take an extra step in which you will have to configure certificates, you will have to configure many things just for monitor your application. This is basically the main restriction and one of the motivation of the telemetric APIs. A telemetric API is basically an API in which you could retrieve the state of your application by using regular HTTP requests to the application server. So if we advance a little bit, we could unite these kind of problems in two questions. How do I choose between JMX or a telemetric API? Which will be the criteria to pick one or the other? And who do I get access to JMX if I'm using a platform as a service? For instance, I've had experiences with OpenShift, with Heroku, and these kind of platforms with Elastic. And it is always complicated to get access to the JMX. And besides this, if you don't configure the JMX monitoring properly, you will be connecting, and the performance of your applications will go down because you will be actually consulting in many repeated instances to retrieve just the information. So that's the panorama in the monolithic sector. So, you know, the reactive applications have been like a buzzword in the recent years because many people is trying to achieve better results for their users. So when you actually are saying, well, we will try to implement microservice in order to give better service for your users, you are actually wanting to implement reactive applications. Why? Because microservices is just a tool that was designed to do better and reactive applications. In the reactive application sector, you will be basically have applications that are message driving, in which the services will be activated depending on how many traffic is reaching your server. So to react better to their traffic, you will have to provide elastic services in which you will be reacting to the peak of the traffic. Let's say if you are implementing software for the banking sector, you will have clear peaks at the end of the month because people will be retrieving the information about the balance of their accounts. After that, 2 or 3 days after that, you will need less resources because you will not require to attend so many queries to your system. And on the other side, you also want a resilient system in which basically you will fail. You have to assume that your system will fail eventually, but like Buzz Lightyear in Toy Story, you will fail with style. So you have to provide alternative paths to fail properly. And with this, you try to achieve responsive applications. So why do we need microservices? Because microservices are easier to start when you need elastic configurations, basically, because you are dividing your systems in this kind of small services in which if one service fails, it doesn't, you know, it only fails and the fault doesn't have to be propagated to all the system. So with that, you will achieve resilient configurations and you could configure dynamically their elastic nature. So in this scenario, we have other opportunities where we will have also other challenges in order to do properly metrics configuration. So the first 3 characteristics of this scenario is that you will have short-lived JVMs, because in an elastic configuration, you will start a microserver again and again and again and again in order to react to the increase of traffic in your system. But after that, this kind of short-lived JVMs will be eventually being exited and the Docker containers will be stopped, because that's what elasticity means. You will be providing dynamically machines in order to react to the traffic, and you will be probably orchestrating this kind of implementations with Docker Swarm or Kubernetes. That I think it is the most popular implementation of orchestration, but the provision will be as needed. But in regards of the metrics, you will have newer problems compared to the monoliths, being the following. First of all, you are running a JVM probably over a container as a service. And your container as a service, you will be probably running in a platform as a service. So you have now 3 layers in which you have to connect. And if you are trying to connect by using JMX, it won't be easier, because you have to redirect the port from the JMX itself inside the container to the platform as a service, to a port open in which you could do a remote connection. So things start to get complicated. And the other consideration that you have to include in your architecture and design is that you will have basically dynamic and ever-changing addresses and ports, because since these processes are being run dynamically, you will be switching IP addresses, port addresses, port numbers, and you have to be more creative in order to provide metrics for your application, because this won't be so easy like connecting to a long-running process. So, and most importantly, if you want to analyze logs, if you want to really analyze the logs of your running applications, you have to go again inside your Docker implementation to retrieve the log. You have to direct this log to another permanent storage in order to analyze them. So I don't know, this looks pretty complicated if you compare it to monolith. So these are basically the main problems that you will face. So one solution for this kind of problems, so this will be like an history that we are presenting. Eclipse MicroProfile is an API, is basically a standard that will give you some alternatives to do your proper metrics. The catch is that with Eclipse MicroProfile, you will be having a standard, so you will need also an implementation, but you don't have to rely only on a vendor, because like in the Java EE fashion, actually with Eclipse MicroProfile, you will be using Java EE regular APIs as basis, like JAX-RS, JMS, CDI, JPA, and Eclipse MicroProfile will complement with some particular APIs your stack in order to give you abilities to achieve better implementations of microservices, including administration, monitoring capabilities, high availability, security, and resources. How MicroProfile is working today, and what could you expect in the near future about this implementation? First of all, Eclipse MicroProfile is a subset of Java EE APIs. These that are you could probably recognize some regular APIs for Java EE developers like CDI, JSONB, or JAX-RS, or JSONP. But over these basic APIs, the MicroProfile project is creating new APIs in order to make it easier to develop microservices. So in this presentation, we will be covering just metrics. There are other sessions that will be covering also the other parts of the stack. But basically, for monitoring and logging, as described in the Devops manifesto, you have two APIs. The first one being metrics that we will be presenting in this presentation, and the other one being health check. What's the difference between APIs? The first API, health check, is focused in just one thing. Like, it gives you the ability to query a microservice to see if it is running or not. That's it. Yeah, it's pretty simple. And the metrics, once the application is running, it is focused on providing you the actual state of 3 levels. How is doing your framework or your execution environment? How is it doing your application? And they have some specific APIs that are vendor dependent. So the vendors have this liberty to implement different metrics in this kind of levels. So how do you add this API? It sounds really good, but how do I use it in my actual Java EE projects? Well, you just need 2 things. That dependency in your POM, or Gradle, you could do the translation, and you need to use a MicroProfile compliant implementation, and that's it. With this, you will be enabling all the set of APIs that I showed you in the previous slide. But you could also enable APIs by using some different dependencies. In here, I am enabling the entire stack because I'm using a full MicroProfile implementation that this Payara micro that I will use in the demos on this presentation. And the other one is that we will show you a particular application in order to show you metrics. You could find the code in my GitHub. It is a pretty basic application implemented by using standard technologies like Java 8, JAX-RS, CDI, AJB, and MicroProfile. So you could take a shot if you want. Okay, people is taking pictures, so. Okay, so Jorge will explain the application in order to give you a little bit more context, and I'll be back in a couple of minutes.
In a traditional way, we are going to develop some applications in this way. We have AJB, GTH, JAX-RS, CDIs. We have data access object, a query database, and all this is in a monolith. Now, in a MicroProfile, in a microservice world, we have multiple services. One service might be dependent on another service. So we have no more items into our architecture. Maybe we depend on an external resource, and remember, if something could fail, it's going to fail. So we have no metrics to know what's happening in real time into our microservices. Another spec we are going to use today in this presentation, in the demo, is the Configure Spec. This actually is very simple. Maybe you have multiple services, you have dependence. You need to know where they are, and something like that. You just inject the config property and config everything you need into your app dynamically. Another API we are going to use is the fault tolerance to achieve a resilient application. Fault tolerance is going to provide us with many metrics. Are going to generate many metrics in our application. We're going to consult with the MicroProfile metrics API and Prometheus or JSON or something like that. With fault tolerance, we have a little example, like the fallback and the timeout. We have a microservice here. It's find by ID. We're going to query the Internet Movie database. But what happens if the Internet Movie database goes timeout, goes down, or just fail? We're going to say we are going to fall back with that method. And this method is maybe a local query to a local database or something like that, or just return a string that says not available at this time. You see, we're not going to go with internal server error or something like that. We're going to go to find by fallback method. Now with the metrics, how can we read the metrics? We can read it by JSON or Open Metrics. That's what Prometheus reads. Maybe some vendor-based format, or an application-based format. Then how we can metric our application? We have some metrics already implementing in the MicroProfile spec, like counted, gauge, method, time, histogram, are going to discuss later. Now, the practical case, use case.
Okay, so how many of you are familiar with microservices patterns? 1, 2, 3. Oh, most of us are familiar. So for those that are not so familiar with this kind of patterns, in the microservices world, when you want to do a deployment like the deployment described in this example, you have to implement some kind of alternative paths in order to do a proper response and to do an alternative wave if one microservice will go down for so many reasons in the network or something. So in our scenario, we have basically 2 microservices in which the client will be connecting to the movie service. The movie service will mix the response from a database that it is implemented at this time in Postgres, and will mix the information while retrieving information from the OMDB service that is just basically a facade for a remote service that already has the plot for the implementation. So how these services look in the MicroProfile implementation? So in here, I have Java EE projects. I have the first project that is the facade for the OMDB demo is over here. Let me increase the font size. Okay, I will close all. And the second service is the Payara demo. So for those who are familiar with regular Java EE development, this looks like JAX-RS implementation, a plain old JAX-RS implementation. How do I deploy this implementation over a microservice environment? So for this presentation, I am using Payara Micro. Payara Micro is basically based on Glassfish embed plus some APIs for the from the MicroProfile project. So first of all, you want to clean and package your application with a regular Maven implementation to create the WAR. And this will be a plain old WAR file. Okay? You will see there is a target directory, and you will deploy it as a microservice in the Payara way. That works like this. You will take the jar file of Payara Micro, indicate it to deploy the application, and for this presentation, I'm using the autobind HTTP parameter in order to order to my microservice implementation to look for the right port in order to don't collide between ports. So I am launching the first microservice, and in the order tab, I will launch the second microservice that is focused on retrieving information from the database and from the already running microservice. So that's the main difference between doing microservices in Java EE. You have to go to another microservices stack. I don't know that Apache Tommy has a similar way to run microservices. I know that Red Hat has this Turntail implementation in which you have like a puzzle of possible APIs that you could include in a just enough application server. But in the end, you will have microservices that are running and are ready to attend my questions. So I will demonstrate the first microservice. In here, I am calling the first microservice, which is running in the port 8080, and I am retrieving a particular IMDb plot of some movie. This plot is for, Pirates of the Caribbean. And this is the plot. How many of you like this movie? It's fine, right? Okay, so let's try to retrieve the plot. Okay, it's over there. And in this microservice, I am mixing information from my local database with the plot retrieved from the internet. So I will reload and expect that all is working. So now it says Capitan Barbosa will turn an Elizabeth Swan, blah, 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 blah. And this microservice has mixed the information between database and the other microservice. So these are actual microservices. Microservices are not about the size of the stack or something, are about these services are focused in doing just one thing, like the Unix philosophy. So how do I demonstrate the fault tolerance? Okay, the most easy way is to turn off the Wi-Fi. And I'll try the first microservice. This will take a while the first time that I launch it, so I will come back to this service. And after that, I will demonstrate practical use cases by using this scenario. We are omitting request cache and circuit breaker just for this presentation, but we are working with a fault tolerance execution. So if the service fails, it will go down and react with an alternative path that will say the plot is not available. And after that, I will mix this plot is not available information with the other microservice. So let me show the code. Let's go over here. So in the Payara demo, in the OMDB demo, I have the implementation of the fallback method, being this one. So I do have a data access object injected using plain old CDI. I do have the first metric that we will be demonstrating. And I have a classic get method for JAX-RS, in which I receive the ID of the movie. In the ID of the movie, I try to get the movie information. But if something fails in this method, I am using the timeout combined with the fallback method, in which you will go to the alternative path, in which I will say, well, the plot is not available. This is dependent of the state of the network and many other variables, but the idea is if you hit the server and the service is down because the remote service is down, you will not fail. You will fail with style like Buzz Lightyear, in which you will offer an alternative path, and I am counting how many times I've hidden this fallback method by using the first MicroProfile API for metrics, being the content metric. This is pretty basic, actually, but it is pretty powerful if you combine it with a monitoring API. In here, I am injecting a counter that is basically the counter for failed queries. And I am incrementing this counter each time I hit the alternative path, because I am in a fallback situation. So I just hit the fallback situation. So it says the plot is not available, basically because I don't have internet. And if I use the second service, what do you think will happen if I do a reloading here? It will say plot not available, because this service is dependent on the other service. So plot is not available. It failed, but it is a resilient service, so it failed with the style. The plot is not available is not so important for this service, so it is OK. And I just incremented the counter for this metric. So how do you analyze the actual metric for this failed situation? Well, the first of all of the options will be to analyze the metrics of the localhost 8080 service. In MicroProfile implementations, you could do it like this. You could go to localhost 8080, and you hit directly metrics. And all the metrics will be available in the Prometheus format. The Prometheus format is kind of a standard that has been submitted and approved on the Cloud Native Foundation. So this is the plain old Prometheus format. So you could actually look for the failed queries counter, and so far it says you've hidden this API 3 times in the failed path. So it is easier because this is a telemetric API. I could continue to hit and hit and hit and hit. Okay, I think I gave it like 18 queries. And this is counting and counting and counting what is happening with your application. And I am analyzing this with a telemetry API in which I could see the actual state of the service. But this is pretty primitive, right? So I could use a metric server, a metrics analyzer like Prometheus. And if you go to localhost 1990, so Prometheus is running, and you could actually query for that metric in Prometheus. Once Prometheus is connected to your microservices by using a service discovery or some kind of directory, you could go and say, I want to know the failed queries in this endpoint. So this metric is in the application level. This application level says this query is in here. I could execute my first query and see it in a pretty, okay, let's don't do this, okay? This is the graph for my failed queries. It is pretty cool. You know, in here in Prometheus, you could define your entire dashboards based on basic queries and combine it with MicroProfile Metrics. So if I continue to hit again and again and again and again the failed query, my service is resilient. It is still running, my entire system is still running, but the failed service is not executing properly. So if I reload and execute the Prometheus metrics, I could analyze what is the situation in real time. So what's the proper implementation of metrics by using MicroProfile? You have to decide how to use the APIs, and after that you have to choose a monitoring tool like Prometheus. I like Prometheus because it's pretty standard. It is actually, as I said, a cloud-native project, so once you choose a stack that has this kind of metrics, you could actually use it and implement it properly like this. So the metric that, as I just showed, was the first one. It was counted. So what's the key idea of this metric? First of all, you have to inject the metric, in which you will use inject. After that, you will use the new annotation metric that it is part of MicroProfile, and this is just a counter. I could manipulate this counter, but it is focused on increment this count. That's it. So each time I hit the find by fallback ID, this will be incremented. It's just a counter, but it is a counter that is exposed over HTTP, and I could combine it by using a monitoring tool like Prometheus. Did you like it? It is pretty cool, actually. The first time that I used this API in production, it was, well, this is powerful, you know. It is a counter. Yeah, each time that you will hit a new microservice, you could actually define an identifier for the service. So if you will be running like 10 or 100 copies of the same service, it will be classified. Once it is like this, you could actually reset it on the API. It's not the, I don't think that if this is a counter of failed queries, you won't be resetting this, but you could do it in the API. It is included. Okay, so the Orion metric is, I think that the proper way to do it in English, I'm not sure, is gauge, I think. So the second one is ideal for increments or decrements counters in real time, because this is basically do your own metric. So you could return anything from your actual query. So what do you think this API is doing? Just to analyze a little bit the code. Okay, this is basically generating a random number, and if this number is odd or even, the gauge will be up and down, and saying in real time, well, this is odd, this is even, odd, even, by switching the values between 100 or 50, that's it. But this was implemented like this to demonstrate what's the idea to implement gauge in your application. So in here, I have to go to the metrics endpoint. After that, I have to go to the application level, in which I have to query the movie database metric. How do you define the name? By naming your metric in the annotation. So if I go to metrics application movie databases, let me show it. Okay, 8080. Metrics applications. Movie databases. Okay, it's not in the service, so it is in this one. Okay, this happens. Let me check it. Okay, let's do it in Prometheus. I think it will be easier. Okay, it is here. You could see that the gauge goes up and down. And so far it's down, it will be up in some point of the random number generator. So gauge is like define your own metric, just for that. Most of the metrics are defined as a continuous state, like the counter, but as a discrete value, of course. And this is defined as a continuous value. So you could use decimal numbers in here in order to plot a little bit better the information of your actually running a microservice. So I think you have some comment in this metric, the gauge. I'll come here. This is being recorded.
It's very simple. This metric type only returns one value. You can to create your own metrics if you have, no? If you need. Sorry.
Yeah, it's pretty simple. You know. So the third metric that you could implement in your application, it's the method itself. This metric is particularly focused on measure the rate of traffic in your endpoint. So in here, I'm annotating the find expanded by ID REST endpoint. And in here, I will retrieve information about the execution and the time of execution of my responses. So it is basically, I am generating this particular number of queries, and I am answering to that kind of particular number of queries, and I am taking this portion of time in order to answer to these queries. I could actually look for these metrics in Prometheus, like movies retrieved. And I could do it by getting the total, the rate per second, the minimum rate per second, the 5 minutes rate per second, or the 15 minutes rate per second. So I basically have this request versus time implementation. And this is available as plain text, as JSON, or connected to a dashboard monitor like Prometheus. So let's just see the total. So far, I have 28 retrievals for this. So let's load it a little bit more. Let's go back. 1, 2, 3, 4, 5, 6, 7, 8, 10. OK. OK, it takes a little bit to update. OK, let's wait for a little bit. So this is the idea of meta-red. You will have the relationship between how many queries are you answering and how much time are you taking to answer to this kind of queries. And the final query will be timed. That is, basically, you are switching the view of how your APIs are executing in your application server or in your microservice framework. So it basically measures the delay on the events and performance. It's just basically just show me the delay or how many times or how much time I'm taking to answer to the users and clients' questions. So let's say Prometheus all, OK. You saw that in real time, I hit the queries, and I could say how many queries I've done to retrieve total. And this is the main idea. Let's go to movies delay. Again, I'm using Prometheus, movies delay. And you will have a lot of information if you use the time annotation. So you will have basically the seconds count, deviation, how many movies have you retrieved per second, the max seconds. So if you are some kind of fanatic of statistics and to measure in real time how your implementation is running, I think this is the ideal metric for you. So you could do this like max seconds. This is how many seconds I'm taking to answer some queries. The first one was 35 seconds. That was the first time that I hit a non-running service. This was the max. 35 seconds, it gave me a timeout. After the timeout, I went to the alternative path, and I answered the plot is not available. So this is the idea of this metric. And finally, you will have histogram. And with this, we are creating an alternative way of implementing the MicroProfile API, in which I am injecting a direct metric registry in which you could manipulate the metric by doing manual coding. So you could actually use metric registry for timed, for meta-red, for gauge, for counted, in which you could provide your own way to create metrics. So in here, I am adding attendees to a particular cinema. So I receive the metadata. In the metadata, I say, well, I do want to create an histogram that is basically an historic record of how things are properly executing. And we will respond OK or fine in this implementation. So that's the idea of the MicroProfile APIs. How to implement it properly, it depends on you, because you have these 5 options to do it. Yes?
Where the server collect this information on the RAM, on the file system?
Now, at this time, it is collected on memory. You could actually configure it in your implementation. As far as I know, Payara, you do it just in memory, because anyways, this microservice will be running for 5 minutes, 10 minutes.
Do you have problems if you have 2 points, too many points to collect this?
Well, it depends on Prometheus, actually, because it is a pool-based technology. So if you have some kind of problem, you will slow down a little bit the retrieval of the metrics, because in Prometheus, you set the parameter and you say, well, I want to collect metrics from this service or from this swarm of services each 30 seconds, each minute, each 5 minutes. So it is mostly a configuration problem, but that's it. So this was our practical use case. You saw many of these kind of metrics in Prometheus. I hope you enjoyed this particular implementation. And what's the good news about this? You could actually use this in monolithic applications, because MicroProfile is not exclusive for microservices. You could actually run this in a monolithic deployment of Payara. If you're replacing some application server like Glassfish, I suggest you to give it a shot, because this is also included in Payara, in Wildfly. It is included in Open Liberty if you are into AVM. As far as I know, Oracle is creating a new microservice technology that sits Oracle Helidon that also includes some kind of metrics. So you could run it to monitor your actual monoliths and how this kind of metric looks. So in the application level, you saw a lot of metrics that are a part of the MicroProfile implementation. But you could also query for the base metrics that are almost the JVM metrics. In fact, if you are monitoring a JVM, you are always looking for memory consumption, heap consumption, garbage collection execution, CPU utilization, and you have all of that available in the base level in your MicroProfile implementation. So how does this look? So many of you that have monitored applications, what do you think this is? It looks like a heap, you know, a heap that is growing and is going down, is going up, is going down. Actually, it is the metric of the heap. Used heap bytes. So it is like using JMX, but over HTTP, so it will be easier. And let's see the second one. What do you think this is? This is the CPU. I'm querying for the CPU utilization of my microservice. And the final one. This is the GC complete execution. So you could analyze the actual state of the JVM by using MicroProfile Metrics. And how do I test it? Well, we could query for the heap bytes, the used heap bytes, and you will see the heap bytes in my 2 microservices. The simpler microservice and the full stack microservice. Of course, I didn't limit the consumption of my JVMs executing, so it could go way upper in here. If you are using a Docker file, you could actually restrict the usage of the memory, and you could see a different performance. But in here, I could see the entire state of the JVMs executing in relation to their metrics. So this is the second usage of that I really enjoy about MicroProfile Metrics. You could also replace some kind of points in the JMX stack in order to see the application. So I think we're out of time, so thank you. I hope you enjoyed this presentation, and I think I have time for one question. So these are my contact. I will be tweeting this presentation in my Twitter in a couple of minutes if you want to give it a shot. And I will include some other samples in this presentation, so if you want it, go to Twitter and see what happens, okay? Well, the thing that with your microservice is that you could actually add a tag to this microservice. So in this presentation, I didn't do that because it wasn't my main point. But you will tag with a particular name, your microservice, and you could actually see how microservices are performing. In Prometheus, you could actually do advanced queries in which you will combine the total state of all of your services that are running in the same swarm. So it basically is mostly basically a form of a matter of how do you create the query over Prometheus, because the metrics are there, are just being processed and pulled up by the Prometheus implementation. Okay, so hope you enjoyed. And sorry for my English, but I'm not an English native speaker, but I gave it my best. And thank you for my co-host for giving me their comments. So.